Welcome to my channel, Chemistry Class. Good morning, everyone. Welcome back to Chemistry Class. My dear student, let me begin today's lecture with a simple question. My dear student, if the nucleus attracts electrons with full force, then why don't all outer electrons feel that same strong pull is inner ones do? The reason is something known as the shielding effect or screening effect. For the student, this is an important topic in understanding periodic properties like atomic size, ionization energy, and electron affinity. Let's understand what is it means, how it works, and where we see its effect on the periodic table. Now, definition of shielding effect. But is student, the shielding effect, also called the screening effect, is the reduction in the attractive force between the nucleus and outer electrons due to the presence of inertial electrons. But dear student, in other words, inner electrons shield or block the nuclear pull on the valence electron. Imagine the nucleus is a magnet and electron is metal pieces, but in between there are cardboard sheets and electrons that weaken the pull on the outermost electron. Now, how does that happen? But is ring and multi-electron atom, the positively charged nucleus attracts electron. Inner electrons repel outer electron and reduce the effective nuclear charge felt by them. So, the actual pull felt by valence electrons is less than the full nuclear charge. So, effective nuclear charge is equal to Z minus A square. Total number of protons, nuclear charge, Z, and as shielding constant mean number of inner shell electrons. Registering more inner electrons, more shielding, and weaker nuclear pull and valence electrons. Now, terms of shielding effect and product table. Registering down the group, shielding effect increases because the number of inner shells increases. Valence electrons feel less nuclear pull, atomic size increases. Example: lithium less than sodium, less than potassium, less than radium, atomic radius increases. Across a period, shielding effect remain nearly the same. Cause electrons are added to the same energy level, but nuclear charge increases. Effective nuclear charge increases, result stronger pull, atomic size decreases. Now, consequences of shielding effect. Shielding effect affects many periodic properties like atomic size. When shielding effect, atomic size increases with more shielding effect. Ionization energy is also increases with more shielding effect. Electron affinity decreases with more shielding. Electronegativity also decreases with more shielding. No example and also comparison. My dear student, example number one: why is cesium more reactive than lithium? Because cesium has more inner shell, more shielding, its outer electron is easily removed. Example 2: why does fluorine have smaller atomic radius than lithium? Because both have minimal shielding, but fluorine has a higher nuclear charge, pulling electrons in more tightly. Now, my dear student, important point to remember, shielding is caused only by inner electrons, not by electrons in the same shell. As orbital electrons shield better than P, D, or F. Poor shielding and G and F block elements explain their unusual trains and size. So, dear student, this was the shielding effect, a very important concept that helps explain periodic trends. But dear student, this is all about today's lectures. If this lectures help you, then don't forget to like the video, subscribe to the channel for more chemistry lectures, and share it with your friends and comment your questions below. Thank you for listening.